So, generative AI is absolutely everywhere, right? But have you ever stopped and wondered, how does it actually get what we're trying to say? The secret behind it? It's not magic, it's math. Today, we're going to pull back the curtain on a core piece of the AI puzzle called vector embeddings and see how they act as a translator for our messy human world into a language that machines can finally understand.
All right, so here's the plan. First, we'll tackle the huge knowledge gap AI has to deal with. Then, we'll discover its brilliant solution, something we can think of as a map of meaning. After that, we'll see how that map gets made, how we search it, and we'll wrap up by exploring the incredible new superpowers this tech gives all of us. Let's dive in.
So first things first, AI's big knowledge gap. Before we get to all the cool applications, we got to start with the fundamental challenge. How do you possibly teach a machine, a thing that's all about logic and numbers, to understand the nuanced, complex, and kind of messy world of human meaning?
And yeah, that's really the heart of the matter, isn't it? A computer's whole world is just numbers, ones and zeros, that's it. But our world, it's a universe of concepts, ideas, feelings, and the relationships between them. How in the world do you build a bridge between those two completely different realities?
You've got this massive communication gap. It's like one side speaks Shakespeare and the other speaks binary. On one side, you've got all this rich data, text, pictures, sounds. On the other, a machine that needs everything to be a number. Without a translator, all that amazing data is just noise.
So how do we build that bridge? Well, that brings us to this really elegant solution. We create a map of meaning. And this is where vector embeddings come in to play the hero, acting as AI's own universal translator.
So what even is a vector embedding? It's way simpler than it sounds, I promise. Think of it like a set of GPS coordinates. But for meaning, it's just a long list of numbers that pinpoints a concept's location on a giant invisible map. A word, a sentence, a picture, everything gets its own unique address.
Okay, now this is the most important thing you need to remember. It's the golden rule for this whole concept. The closer two sets of coordinates, two vector embeddings, are on this map, the more similar their meanings are. That's it. Simple as that. On this map, distance is meaning. Let's make this real for a second. So on this map of meaning, a sentence like "a little boy is walking" is going to be plotted right next to "a sad boy is walking." Why? Well, because they're conceptually really similar, right? But a totally unrelated word like yellow? No way. That's going to be in a totally different part of the map, miles and miles away.
Okay, so we've got this incredible map where distance equals meaning. Cool, but that begs the question, who's the cartographer? Who or what actually draws this thing? That's what we're getting into next.
You know, it wasn't always this easy. The old way was a total grind. It was called manual feature engineering, where a person, an expert, would have to sit there and painstakingly assign numbers to everything. It was slow and it just couldn't scale. But now, the new way is just so much smarter. We use these specialized AI models that basically teach themselves to translate everything into these vector embeddings for us, and they do it in an instant.
And you gotta know, it's not like there's one single model that does everything. Nope. You've got specialists, you have models like BERT that are geniuses with text, you have others like VGG that are amazing with images, and the list just goes on and on for audio, video, you name it. Each one is a master translator for its own kind of data.
All right, so we can now turn pretty much anything into a coordinate on this giant map of meaning. But what good is a map if you can't actually use it to find anything? So, how do we search it?
And you can't just throw this into your standard everyday database. Those things are great for finding an exact match, but ask them to find the closest idea, they just can't do it. For that, we need a whole new kind of tool, the vector database.
So what these databases do is pretty amazing. Their one job, their superpower is this. You give them one of these meaning coordinates, and they will blast through billions of others almost instantly to find its nearest neighbors, the other items that are most similar in meaning. Companies like Pinecone and Weaviate, they're basically building the Google Maps for this entire universe of concepts.
Let's walk through a real-world example, like a Q&A bot. Okay, step 1, a user asks a question. Step 2, boom, that question is instantly turned into a vector embedding. Then the vector database does its thing. It hunts for any documents that are close by on the map. And finally, it spits out the most relevant ones as the answer. And here's the magic. We just searched for meaning, not just words that matched. That is a total game changer.
You know, this stuff isn't some far-off future tech. It's already here, running in the background of things you probably use every single day. So for our last section, let's check out the amazing new superpowers this gives us.
And you can see just how fast it's spreading. But look, two areas are way out in front: recommendation engines and enhanced search. I mean, when you think about it, that's a massive part of our digital lives, right? Let's talk superpower number 1, recommendations that actually get you. Next time a streaming service suggests a new show you end up loving, this is what's happening. They're not just looking at the genre. They're taking what you just watched, turning it into an embedding, and finding its closest neighbors on the map. It all comes back to that golden rule: closeness equals similarity.
All right, superpower number 2, search that actually understands what you mean. You're not just stuck with keywords anymore. You can literally search for a vibe, a feeling, like a moody, symmetrical film shot, and the system finds results that match that concept. It's the difference between searching for chicken recipes and searching for a cozy, comforting weeknight dinner. See the difference? It's huge.
And for our third superpower, we're going to flip the script a little bit. Fraud detection. Instead of looking for things that are similar, we're using this exact same tech to find the one thing that's wildly different. We're looking for the needle in the haystack.
So check this out. Imagine all the normal, everyday transactions are plotted on the map. They're all going to form a nice, tight little cluster, right? Because they're all pretty similar. But a fraudulent one. By its very nature, it's an anomaly. It's weird. So its embedding lands way out in the middle of nowhere, all by itself, far away from that main group. It literally sticks out like a sore thumb, making it super easy to flag.
Now, as amazing as all this sounds, it's really important to keep in mind where we are on the timeline. Just like Colin from the Colin Talks Tech channel puts it, the space is still relatively in the early days and evolving quite quickly. What we're seeing right now is just the tip of the iceberg.
So, when you boil it all down, we've figured out how to translate our complex, messy world of meaning into a language that computers can understand and navigate. The implications are just staggering. We can now chart the conceptual universe of, well, anything. And that leaves us with one heck of a question to think about. Now that we can do this, what should we map next?